which are monotonic sequences. Let's start with n over 2 to the n. What we need to show here is that a n plus 1 is less than or equal to a n, because it's pretty clear that the denominator grows much faster than the numerator, and therefore we expect this to be a monotonically decreasing sequence, and therefore a n plus 1 less than or equal to a n is what we want to show. By definition, that means n plus 1 over 2 to the n plus 1 less than or equal to n over 2 to the n. To verify that this is true, we can establish an equivalent statement. By cross-multiplying, we get 2 to the n times n plus 1 less than or equal to 2 to the n plus 1 times n. I'm going to write that, though, as 2 times 2 to the n instead of 2 to the n plus 1, but still multiplied by n. The reason why I want to do that is because since there's a 2 to the n here and here, I can just cancel them off. Now, I've established an equivalent but much simpler statement. So if I can prove that this simpler statement is true for all n, or all n greater than some fixed value, then I've established this statement, and therefore I have a monotonically decreasing sequence. Now this is pretty reasonable because we have n plus 1 less than or equal to 2n. If we subtract n from both sides, this will say n is greater than or equal to 1, and there we go. Anytime we start with our sequence for n greater than or equal to 1, this will in fact be a monotonically decreasing sequence. Now, for the next one, we can use a different approach. We can show that the function f of x equals x over ln x plus 1 has a positive derivative. Now, the reason I would go with that is because n grows much faster than natural log, and so I expect that this is going to be a monotonically increasing sequence, and therefore I want to show that the first derivative is positive. To compute the first derivative, simply apply the quotient rule. Bottom times derivative of the top, which is 1, minus derivative of the bottom, multiplied by the top, all of this divided by the bottom squared. Now, this derivative is going to be positive precisely when the numerator is positive. Now, to show that this is true for all x bigger than or equal to, say, 1, then what we'll do is let x equal 1. Then what we have is ln 2 minus 1 half. And using our calculator, ln 2 is about 0.69. And so this, in fact, is going to be greater than 0. Now, what we want to show is that this is true not just for x equal to 1, but that this is true for any x bigger than 1. So what we can do now is show this, in fact, has a positive derivative. And therefore, since it's positive when x equals 1 and it has a positive derivative, this numerator is going to always be increasing, and therefore it's always going to be bigger than 1 essentially. Therefore our overall derivative is going to be always positive, proving the monotonicity of our sequence. Okay, so we got that. Let's go to it. So the derivative of this expression now, which we know is positive at 1, to show that it's always increasing, so that it's always going to be positive no matter what, we apply the derivative of that. So differentiating, we get 1 over x plus 1 minus, and we have to apply the quotient rule one more time, bottom derivative of the top minus derivative of the bottom times the top over the bottom squared. And some nice stuff happens. We have x and minus x, which are going to cancel. We'll get a common denominator of x plus 1. And so that means the numerator in our first fraction is going to be x plus 1. The numerator in our second fraction, after the x's cancel, is just going to be negative 1. And therefore, plus and minus 1 cancel. And so finally, yes, this is always going to be positive because x is greater than or equal to 1 by assumption. Therefore, this part right here is always positive because it's 1 and then it's increasing, and therefore our derivative is always positive. So if you didn't get that on your exercise, I don't blame you. So that was a tough one, but there it is. So we can use the derivative or we can calculate directly. For C, sine n, well, again, we don't really have much control over n. N is just an integer now, 1, 2, 3, 4, 5. And so we're going to have some positive, some negative, no matter what n value of n we have. And so this sequence right here is not monotonic at all.